All right. Hey, everyone. I think we're just gonna continue to let a few people jump on here. In the meantime, I'm gonna launch a poll and I will introduce myself and today's topic. So I'll just give you guys kind of a minute to do this while I just make a couple introductions here. My name is Neva Parker. I am the Director of Operations here at White Labs. I've been with White Labs, gosh, for a long time now. It doesn't feel that way, but it's been, what, 17 years now? 2003 is when I started, so been a pretty fun ride getting here. So I wanna welcome you guys to today's webcast. Today we're gonna talk about sort of beyond beer, other fermentation products aside from beer. We'll talk a lot about nutrition, pitch rates, you know, things along those lines that will help make some of those other fermentations really successful. All right, so it looks like got a few more polls coming in, so I'll just give that another few seconds. Looks like the majority of you are brewers and enthusiasts, so welcome. I hope you're all surviving these stay-at-home orders. Personally, I've been alive. My household is alive, so I think that's positive. All right, so I'm gonna go ahead and end the poll. Thank you guys for getting on that very quickly. Okay. So as I said, we're gonna talk about fermentation beverages beyond beer today. And, you know, here's kind of an outline of what I'll go over. We'll talk about some of the different beverages and some of the organisms that are used for fermentation of those beverages. We'll go over some of the sugar sources and how that can affect the metabolism of the yeast, different types of sugars, you know, whether it's simple sugars, whether it's grain wort, et cetera, et cetera. We'll talk about nutrition additions and the importance of those, and fermentation temperatures and pitch rate and how that can affect some of the flavor compounds that are produced as well as the performance of the yeast. I also want to mention that if you have questions, you can feel free to post those in the Q&A section of your screen. Please try to use that instead of the chat function. It'll be a lot easier for us to find those questions. And I will take those at the end, but if you think of something, please feel free to go ahead and type those into the Q&A box as we go. All right, so for today, we're gonna cover a few different beverages here, including cider, hard seltzer, hard kombucha, mead, wine, spirits, sake. These are, you know, different than beer, but also still alcoholic beverages. Commonly, you know, there are some similarities to the organisms that are used to beer. A lot of these can be fermented with Saccharomyces cerevisiae, which is your traditional brewer's yeast. But oftentimes you'll see other organisms present too, particularly in some of these, you know, beverages like kombucha. You'll see Saccharomyces baianus, that's your common wine strain. Different strains of bacteria like Aspergillus, Acetobacter, Lactobacillus, and then of course some of your wild yeast. So there's plenty of different organisms here, and you know, how they're used and which ones are used are really going to be dependent on the beverage itself and what kinds of flavor profiles you're looking for in some of these things. So when we're talking about each of these different kinds of beverages, it's really going to be dependent on that type. There's going to be recipe adjustments considering what you're making. So each product is going to require something unique. And a lot of that is really going to have to do with the starting point of sugar content. What is your base carbohydrate that you're going to be using for production of these beverages? That can really vary. And we'll talk about some of the metabolism related to those sugars in a minute. And then, of course, once you have that selected, looking at yeast selection, is that yeast going to perform well with that carbohydrate base? And then what nutrition requirements are we going to have based on those two scenarios? There are also lots of things that can be adjusted to help make that fermentation successful, like pitch rates, fermentation temperatures, and both of those things too will help contribute to some of the flavor profile of the finished product. So we'll want to consider all of these things when we're looking at recipes for any of these beverages. And this is very true also for beer, but much more so, especially with the nutritional aspect with these alternative beverages. So talking about flavor impact for a moment, because I kind of keep mentioning that there are some flavor considerations here. And some of those things can be controlled through adjusting the recipe. And that could be, either with the yeast strain, that could be with some of these temperature profiles that we're talking about, or pitch rates. And we know that yeast will produce ethanol, alcohol, and CO2 as the primary metabolic byproducts. But there are also a lot of secondary byproducts that are produced, and that carries through to the finished beverage. And some of those things include esters, which are the fruity, kind of floral compounds, higher alcohols other than ethanol. So, these would be the ones that may contribute some of the hot solventy character to a fermented beverage. And we want some of that for complexity, but probably not at such a high level that it's going to come across as really hot. So those are some things to consider. Vicinal diketones, like diacetyl. Diacetyl is buttered popcorn. I'm sure we're all very familiar with that. Aldehydes, and that's primarily acetaldehyde, which is a green apple, fresh cut grass, fresh cut pumpkin, that sort of flavor compound. Phenolic compounds. Phenolics are going to be your spice, clove, pepper, and really, if we're talking about Saccharomyces cerevisiae, only a handful of strains will produce those compounds. Primarily, you'll get those from some of the wild yeast, like Brettanomyces, and any other wild yeast you may be using. And then also there's organic acids, sulfur compounds, fatty acids, in smaller quantities. All of that can contribute to complexity of the beverage itself. But, the majority of the compounds that you're going to see produced that are detectable are going to be those first 4 or 5, depending on the strains. So a lot of times we talk about off flavors when it comes to what's being produced by the yeast. And in cases like this, off flavors can result from lots of different things that cause stress to whatever organism you're using. And that can be from lack of nutrients, maybe choosing the wrong strain to use in the beverage, whatever it may be. Incorrect pitching rates, either too high or too low. And also, if you've got fermentation temperatures that are not regulated, that can really lead to some off flavors in that beverage. So there's a lot of different things that can be controlled, that really need to be controlled in order to produce the desirable flavor compounds and avoid some of these off flavors that we're talking about now. So kind of based on some of that, let's kind of move on to talking about carbohydrate source. So any fermentation is going to require some sort of carbohydrate source. This is the main food for these organisms that will allow them to really undergo metabolism. So there's a lot of different sources that can be used. And when we talk carbohydrates, it's mostly providing available sugar compounds for these organisms to metabolize and ferment. They can come from a variety of sources, grain, and that's, mostly with beer production, we're working with grains, but also can be used in a lot of different beverages as well. Honey, molasses, different types of fruits, also just straight processed sugars, and other, vegetables, potatoes, especially with spirits, lots of different sources. If you've got carbohydrates and you can break those down into sugars that can be metabolized by yeast or other organisms, it's usable for beverages. And we know that these sources are going to be complex carbohydrates, and those will need to be broken down into something simpler for the organisms to be able to use. Now, some of these organisms, of course, are capable of fermenting larger chain sugars. We know that brewer's yeast or Saccharomyces cerevisiae, for the most part, can really only ferment up to a 3-carbon sugar, and that's up through maltotriose. So, maltose, glucose, maltotriose, those are really the primary fermentable compounds for Saccharomyces cerevisiae. And, some of these other organisms like Brettanomyces, for example, can also ferment dextrin. So those are things that we'll have to keep in mind as we're building the carbohydrate source and matching it with the correct strain or organism in order to be able to do the fermentation. So a variety of sugars come from these grains, or just simple sugar itself, and those are kind of listed here: sucrose, dextrose, maltose, maltotriose, glucose, fructose, dextrins. So the simple sugars, the really small compound sugars, sucrose, glucose, fructose, those are all single carbon sugars, and they're going to be fermented very quickly by almost all organisms. So those are sometimes favored in some of these beverages like hard seltzer, because they're really easy to ferment. So as I kind of mentioned, we start with our carbohydrate source, we understand what we're going to be using. It's really important to select a strain that works for that environment, and also to produce the desired flavor compounds within that carbohydrate source itself. So some of the things we'll have to look at besides the ability to ferment whatever carbohydrate is selected is alcohol tolerance. If you're trying to make a really high alcohol beverage, you've got to select a strain or an organism that is capable of tolerating high alcohol. Otherwise, you're just going to get stuck fermentations. So those are things to consider. Thinking about your end product and what that profile is going to look like, and sort of working backwards from there. Some other things to also think about is, what is that nutrient requirement? Again, that's going to be really dependent on your carbohydrate source, and I'll talk about that in more detail in just a sec. But nutrition is really, really important for yeast. They require a lot of micro and macronutrients, and if they don't have them, they're going to ferment very poorly. So we want to make sure that we think about what those requirements are. Speed and performance, depending on what you're producing, that might be important to you. You might want to, if you're trying to make something very quickly, or if you're looking at turnover at a production plant, you need that speed and performance so that you can turn over your fermenters and your tanks very quickly. And also fermentation temperature range. Sometimes it can be challenging to maintain fermentation temperatures appropriately, especially if you're working with lower temperatures. So thinking about what's available to you and what capabilities the strains or organisms that you're using will have in terms of the fermentation temperature. All things to consider when selecting the correct strains or collection of organisms that you want to be using. So, I've talked a lot about needing the right nutrients, and nutritional programs for these fermentations are going to be really important to avoid any kinds of stalled or stuck fermentations. Grain from malted barley, for example, provides a really good and adequate source of nutrients for yeast. Malted barley has nitrogen compounds. It's, of course, got carbohydrates, which we already know, and lots of other vitamins and trace minerals that the yeast will need to ferment. So if you're using malted barley, which is what most brewers do, it's no problem. The majority of the beverages that we're talking about today are going to lack most of that nutrition because they're typically coming from simple carbohydrates. More of those sugar compounds, even things like honey and molasses are really, really lacking in nitrogen compounds that are needed by yeast and other organisms for successful fermentations. So with that, adding yeast nutrients and particularly FAN, free amino nitrogen sources, will help supply all of the necessary minerals to really get a good fermentation going and keep that yeast or those organisms very healthy throughout the course of the fermentation. So wanted to take a quick look at just mead specifically because we had some data that I wanted to share. And this specifically looks at different types of nitrogen sources and also the timing of those additions and how that affected the overall fermentation. So in this case, in this set of trials, there were two different sources of nitrogen that were used. There was an organic nitrogen, which was Fermate-O in this case, and there was also inorganic nitrogen, which was diammonium phosphate, DAP. I'm sure you guys have heard of both things. And really what we wanted to look at here was what type of nitrogen source would be most effective throughout the course of a fermentation in mead. And this was a study that we did with Lost Cause Meadery, which is local here in San Diego. But as you can see, using the Fermate-O, which is the organic source of nitrogen, you get very similar fermentation curve. And this is really just a drop in degrees Plato over time. So you get pretty close fermentation. When we look at the yellow dots, which is a combination of DAP and Fermate-O, it's 2 parts DAP to 1 part Fermate-O, we start to see slower fermentation. And DAP is that inorganic nitrogen source. So it's kind of interesting to see that by using more DAP versus the organic nitrogen source, we're getting a slowdown in fermentation. Everything kind of starts the same, they're dropping at the same rate, and around day 7 or so, we start to see them vary. So it's important to understand that using DAP alone or using a majority of DAP is not the ideal according to this study. Similarly, looking at dosage rates of the nutrients and how that affects fermentation. So this is a look at a hard seltzer fermentation with 2 different amounts of nutrients. And this is basically using a product that we just released called FanMax. And it's a mixture of different peptones, fatty acids, nitrogen compounds, and vitamins. And this was at 2 different dosage rates, as you can see. There's a 200 grams per barrel and then 250 grams per barrel dosage rate. And you can see immediately with the higher dosage rate, we're getting a faster fermentation, a faster drop in gravity. And then the final gravity is also lower than the 200 grams per barrel pitching rate or dosage rate. So in a case like this, the higher the amount, the better the fermentation was. I would also just add a caveat that you'll want to really look at sensory of the product at the end. Sometimes when you get too fast of a fermentation, you get more of those higher alcohols being produced. So it's sort of a give and take in terms of how much nutrition you need versus what that sensory is going to be at the end of fermentation. I want to make a quick note also just about DAP in general. DAP is something that's often used because it's cheap, it's easy to get, and you know, I really think that DAP by itself is not a great nutritional product for yeast in general. It's good when it works with other types of organic nutrients. And that's kind of apparent in the previous slide that I showed, which is here. And really the reason for that is think about DAP as sort of like a Red Bull, right? You take it, you get a quick high, but then it wears off really quickly, or even like a candy bar. It just gives you a quick shot of sugars that helps boost you, but it's not sustainable. And that's where a lot of these organic nitrogen compounds are better. It's sort of like a slow release of those nitrogen sources that the yeast or organisms can take up over time. It just takes them longer to metabolize that, which is actually good. It helps sustain those nitrogen sources over the course of fermentation. Instead of being really easy for the yeast to metabolize, they take it up very quickly, and then they sort of just like go to sleep because they came down from their sugar high. So like I said, DAP is great to provide some nutrients for the fermentation, but you'll also want to pair that with another nutritional source that's really going to be more of that sustained nutrient requirement. Okay, so we went over that. And the other piece of this puzzle, right, is pitching rates. Pitch rates are important because we want to ensure successful fermentation. Having too much or too little yeast or organism, whatever you may be using, is going to affect the fermentation. And really, the pitch rate depends on a lot of different things. Everything is sort of connected together, and that's what makes some of these things very complicated. But you know, fermentation temperature, what is your starting gravity? That is probably the biggest thing. If you have a high gravity fermentation that you're going to be starting, having the right pitch rate is super important because you want to make sure that you have enough culture in there to be able to complete that fermentation. Oxygen as well, you know, like beer fermentations, oxygen at the beginning of fermentation is still really important for the yeast. That's not limited to just, you know, wort and producing beer, but really any fermented beverage, especially when you're using, you know, yeast as opposed to bacteria, for example. The strain that you use can help determine what kind of pitching rate you need. And then nutritional requirements, of course, will help kind of support whatever pitch rate you have. So it depends on, you know, a lot of different factors, and there's more than just those things, but these are sort of the main ones. And I would say really your starting gravity is going to be the first thing you'll need to figure out in determining that pitch rate. So here's an example of the different pitch rates for these kind of different beverages that we're talking about. And these are, you know, very general. Wine, mead, and cider all have very similar sort of recommended pitch rates. And this is pitch rate in the beverage. So whatever you end up with in the beverage itself is sort of where we've landed with this 5 to 8 million cells per mil for kind of those three beverages. Looking at hard kombucha, seltzer, similar ranges, mostly because what we have there for the most part is very, very simple sugars like sucrose, fructose, things that will ferment very quickly. And some of that pitch rate is, you know, much lower than the wine, mead, cider group because you want to control some of the fermentation temperatures. And one way to do that is by lowering the pitch rate slightly so you don't get just like a super fast fermentation that's going to get really hot. that will help avoid some of these things like the fusel alcohols and making those beverages start tasting or smelling really solventy. With spirits, there's a big range. It really depends on the spirit. 10 to 20 million cells is pretty typical. And that's going to be, again, sort of dependent on what you're making, what kind of alcohol you want to end up with prior to going to the still. So there's some considerations there. And then of course with spirits too, I mean, you have such a wide range of carbohydrate sources that you can be using that will have some impact on how much you want to pitch, but that's the general range. And then of course, I want to mention, as I kind of did on the last slide, if the starting gravity is on the higher end, and here I just added, you know, if it's over 16 bricks, 16.6 Plato, 1068 specific gravity, you'll need to increase the pitching rate accordingly, just because we're working with more carbohydrates now, and we've got to have enough healthy yeast or culture in there to make sure that we're able to complete the fermentation. So obviously too, when we're talking about these beverages, the wine, mead, cider, you know, seltzer, spirits groups are going to be predominantly using some sort of Saccharomyces strain, whether it's Cerevisiae or Baianus or something within that strain category. Hard kombucha is going to have a plethora of different organisms that are used. That's another reason for some of these varying pitch rates. But you know, you've got some yeast, you've got some bacteria cultures, you've got all kinds of different things in that kombucha, but it's a general range of what we would likely see of organisms within a SCOBY, for example. And then fermentation temperatures, and this is really just sort of, you know, recommended. Certainly a lot of things can happen outside of these ranges, but there are some considerations you'll have to make if you do work outside of these ranges. And most of these ranges are really looking at the organisms that are specific to these beverages and where they perform optimally. You can see with wine, there's also a big range, and that's really just strain dependent and also wine dependent. You know, there are some wines that you may be okay fermenting at the high end of the range, and some that you need to ferment much cooler to kind of maintain some of those flavor compounds or minimize some of those flavor compounds that are being produced. Same thing with spirits. You know, most of these beverages can be, like I said, fermented at varying ranges, and just keeping in mind that as we lower the fermentation temperatures, we lower somewhat the yeast activity or the activity of the organisms that are being used in the fermentation. And that will often lead to, you know, muted flavor byproduct production. So if that's what you want, that is a way to control some of those flavor byproducts. If you want a lot more flavor compounds, you know, normally you would try to ferment at the higher end of the range to help kind of promote some of those flavor compounds like esters and things like that. Of course, assuming that the strain that you choose is capable of producing those compounds even at the high levels. There are some strains that are going to be super neutral, and no matter how high you ferment them, they're not going to give you a lot of ester compounds, for example. So keeping those in mind, strain selection is important in keeping with these kind of temperature ranges also. All right, so we're getting to the end, or we are at the end. So, you know, you can kind of see with these beverages, it's all very unique. And without talking about each one individually, there are still a set of requirements that are going to be important no matter what. And that's, you know, nutrition and having the right amount of nutrition, adequate nutrition. Also considering the pitching rates for all of these beverages to make sure that we're getting good fermentations in the first place. And then using things like temperature to control some of these flavor components that you may be trying to get out of these beverages. And those are all controllable factors and really sort of play into that recipe development for those beverages, and really understanding what the organisms are capable of that you're going to be using, and then looking at your process to make adjustments there to get to that sort of final product that you really want to produce. So even though the starting recipe for these things may be different, there's a lot of very general things that you can follow in regards to, requirements for nutrition, pitch rates, temperature, and really just trying to provide that for you guys today. So hopefully that helps give you some insight, in terms of what you may do with these alternative beverage. And happy to take any questions now. Okay, so a couple questions here. Can I boil my yeast from the previous batch to provide nutrients for the next batch? That's a great question. So the interesting thing about using yeast from a previous batch as sort of like that yeast extract kind of thing, it's definitely possible. The challenge is that in order to really get the most out of the yeast extract, if you will, you really have to lyse the cell, and that just means you've got to break it open. Oftentimes just boiling the yeast doesn't accomplish that. When yeast extract is made, it's typically held at a steady, like hot temperature for about 48 hours in order to get the cells to break apart. And that's really what you want to get to. You want to get those components of the cell wall to really break up, because that's where all the nutrients are. If you've got just like dead cells in there, that doesn't always give you enough for the yeast to be able to use. So you've got to be able to break apart those cells. And I will tell you that I have before made yeast extract in my home in a crock pot, and that generally works. It smells really bad though. So if you're gonna do it, and if you live with someone in your home, you just let them know that that's what you're doing and it's gonna stink, or do it outside. But those are ways to do it at home. But yeah, just boiling alone is not gonna necessarily do the trick. But hot, steady temperature is what does it. Slow cooking. I was told that using wine yeast is better for seltzer or cider due to its compatibility to lower nutrient bases. Any thoughts on that? Certainly the nutrient requirements are different. And really the thing with wine yeast is that they are more capable of fermenting those really simple sugars, like, sucrose, fructose, those sorts of things. Brewer's yeast can ferment those as well, but they are not as efficient at it because they're used to maltose and they really prefer maltose. So yes, oftentimes, either a wine yeast or a yeast that's specific for distilling for spirits is better at the hard seltzers, just because of not necessarily the nutrient requirements, but just because of the efficiency of fermenting those simpler sugars with good tolerance. WLN 2000 sounds amazing. That's the FanMax bio. What yeast would you combine with this for seltzers? So I think really, as I kind of just mentioned in the last question, brewer's yeast works well, but because, as I said, they're more apt to ferment in a maltose-rich environment, something like a wine yeast works really well, and pretty easy to find. We also have a bunch of different distiller strains, at least, for us, I can make those recommendations. Pinnacle is something that we carry, and it's a distilling strain. So any kind of distiller's yeast, of course, 001, California yeast is always a good strain for anything. So those would be I think, good strains to use for hard seltzer with the FanMax. Any recommendations for how to back sweeten a mead and not restart fermentation? That's a good question. I think really the only way to do that is to try to remove as much of the existing yeast as you can. You know, for the most part, when fermentation is complete, the yeast will drop out. So if you can clarify the mead and then back sweeten it post removal of yeast, that'll be a good way to do it. And you know, really you can use any sugar source at that point. But yeah, you'll have to remove the yeast or as much of it as you can. And as I said, for the most part, you're getting, you know, the majority of the yeast to settle out, so you can transfer that off the yeast and be able to have a clear product that you can back sweeten. So I guess that's it for questions. Unless anyone has anything more that they want to cover, you know, we'll be posting this. And sorry, one more question, 2 more questions. All right. Can I cold crash and back sweeten? So yes, that's sort of, as I was mentioning, it's probably the best way to do it, because then you can get most of the yeast out of there and get the sugars back in there and avoid re-fermentation. What is the best yeast strain to use for hard kombucha? You know, that's a good question. We have a SCOBY that we use. It's got everything in it and it will produce alcohol. That's probably your best choice. If you want to go with sort of your own mixture or sort of creating your own culture for hard kombucha, you know, I always like 001 just because it's the easiest and it's so versatile and capable of doing pretty much anything. But you'll want to mix that with some bacterial cultures, you know, lacto, acetobacter, probably some wild yeasts in there to really duplicate what is in a SCOBY. So that would be my recommendation. Question, is Fermate K less efficient than Fermate O? Or is it better than DAP? So Fermate K is very similar to Fermate O. The only difference is that there's organic sources of nitrogen in Fermate O. So if you are looking at organic products, for example, you would probably choose Fermate O, but really similar products, they do similar things. In the study that we did, we were just looking at Fermate O as an organic versus inorganic, not necessarily versus Fermate K. But that can also be used in combination with DAP. What non-traditional mead and wine strains would you recommend for fermenting meads? So yeah, that's a great question. We actually have some information on our website, but we have used some English ale strains in some studies on mead. 002 works really well. 007. 007 is a great strain because it is also pretty alcohol tolerant. So it has a really healthy fermentation in mead and still produces a pretty clean product with some nice character. So I would try 007, 028, and I'm speaking only of the strains that I know that we've used here. So those are some ones that I would recommend trying. All right, I think that's it for real this time. So we will be posting this on our website after this is over. So if you missed any of it or you want to rewatch any of it, it will be posted there shortly. And I guess without any further questions, thank you guys for taking the time today. I hope you learned something and stay healthy out there. Thanks a lot.